All right, we're going to do binary tree vertical order traversal. So they just want us to think of the tree in terms of like vertical columns. So for example, the first column in this first example would just be 9, and then the next column would be the 3 and the 15, and the next column would be 20, and the next column would be 7. So we're just going left to right in and thinking of it vertically. And then whenever there's a conflict, so for example, this first column is a 4, this next column is a 9, but then on this third column, uh, so the top node is a 3, but then when there's a conflict, you can see that the 0 and 1 uh, aren't in the same row and column. So whenever they're in the same row and column, we just go left to right. So that's how we get 0, 1 here. And then 8 and then 7 are the last two columns. All right. So what we're going to do is we're going to do a breadth first search while keeping track of what row we're on and what column we're on. All right, so let's start by creating the thing that we're going to return. And I'm going to make this a linked list because in the breadth first search, we're actually going to add to the head or tail of this linked list. We're going to add the column to the head or tail, depending on whether we encounter a negative number or a positive number for the column, because the first column, so the root, this is going to have column 0, but if it's say we get a left, say root has a left child, right? Well, the root.left would be column -1. So what I'm going to do is whenever I encounter a new negative number that I haven't seen before, I'm just going to add the column to the head of the result. And if I encounter, say, a positive number like 1 or 2, whatever, I'll just add it to the tail of this result. But you'll see that in a second. So anyway, let's create a list, or sorry, a map of columns to a list of integers. And what this is going to do, it's going to map columns to this list of integers here, because it's just a nice way of being able to check very quickly whether I have a column or not, and then grabbing an O one time. So let's create this hash map, and actually let's give this a better name. Let's call this call to list map. Okay, and we'll handle if they give us an empty tree, and we'll just return the result. Okay, now we need to keep track of what row we're on. What's really important is that we know whether we're on the same row or on some other, on the next row or not. But anyway, what I'm going to do is I'm going to create a pair of integers to tree nodes. So this is mapping the column, because we need to keep track of what column we're on, to the tree node. And this is just like a breadth first search where we create a queue, but instead I'm going to call this row, because I need to know whether I'm on the same row or not. And then what I'm going to do is I'm going to create a next row queue and set that row to the next row whenever we're done processing the current row. And again, you'll see in a second. Okay, so let's add the root node to this. So we have to create a pair. We're going to pass in 0 for the call, because the root is at column 0 when it starts, and we'll pass in root. Okay, and now we just do a breadth first search. So while row.is empty, or while the row isn't empty, then, okay, so we actually want to copy paste this one more time, because what we're going to do is we're going to go through all the nodes in this row. And actually, let me declare this really fast so I can explain better. And I know this looks like magic, but it'll make sense in a second. I'll explain it really fast. So I'm declaring this next row, and what I'm going to do here inside of this while loop is I'm going to go through all nodes on this row and add children to next row. So I'm just going to go through all the nodes in this row and add the children to the next row. And then what I'm going to do down here is say row equals next row, so that we can process the next row in the next iteration of the loop. Okay, so let's keep going. So what do we want to do? We want to pull the node. So we're going to do pull tree node, or sorry, what do we want to call this? I'll just call this pair. Yeah, we'll call it call node. equals row dot pull. So we're grabbing the node out of the queue. And let's just take this out so the code looks nicer. Because I don't want to call get key over and over again. And we'll grab the tree node while we're at it. So tree node call, and this is, what you call this node, equals row.getValue. So this is just grabbing the column. This is just the pair API in Java. I know it's get key and get value. They're weird names for a pair. I would call it get first or get second, but whatever. Get key is going to get the column. Get value will get the node. Okay. And so now what we need to do, we need to check if we've encountered this column before. And if we haven't seen it before, we need to create a list for this column so that we can add it to our result. So we're going to check if our call list map, if it contains the column. So it contains key, pass in the column. And if it doesn't contain it, we need to create it. So let's create a list of integers. And we'll just call this column. Okay. And we're going to put this in our list map. And we'll pass in call, pass in the column. And we also, okay, so what I'm going to do here is this column list that I just created, I need to add it to my result. So if it's a negative number, if this is the first, so what I'm going to, yeah, so if it's a negative number, I'm going to add it to the head. If it's a positive number, I'm going to add it to the tail. And that works because I'm finding these positive and negative numbers incrementally. Like I'm never going to see, for example, I'm never going to see a -5 column before -4. I'm always going to go in order, right? I'm going to see a 0, a -1, a -2, a -3 because the tree expands like incrementally as we go towards left and right children. Okay, so let's check if this column is greater or equal to 0. So if it's greater or equal to 0, then I'm going to add it to the tail. Or we could do, yeah, let's just do it like that. So we'll do call, what am I doing? Result dot add the column. Yeah, so this will add it to the end of the result because this is a positive number, and else we'll add it to the tail of the head of the list, of our result, because this is a negative number. So we'll add the column, and so I like to do it like this, but I've seen, what is this doing? I've seen other people, they keep track of like a min column and a max column, and at the very end, what they do is they loop through their from min call to max call, and then they add the columns that way. But this is, I think this works just fine. Okay. Okay, so what are we doing now? We added our column, and now we just need to add, so we need to add this node to that column, or the node's value to the column. So, okay, so if we didn't have the column, we're going to create it here. And now that we've created it, we can just say list integer column equals call list map. So we're just going to grab the column now. Cool. So if it wasn't created, we created it, and now we have it here. Okay, and we're going to say we have to, it's okay, so what are we doing here? We have to add the node to this. So let's just do node.val. And are we good? What am I missing? I feel like I'm missing something. I grabbed the column, I added the node value, and oh, we actually need to finish the breadth first search. So we never added the children to the next row. So if the node has a left child, then, because we're going left to right, right? So we're going to add this to our next row. And we'll add node.left. And oh, we actually need to turn this into a pair because we're keeping track of columns here. So this is going to be whatever the column is. Because it's a left child, we're going col -1. Because if this is 0, if say, okay, for example, the root is column 0, we need to pass in -1 for the left child for the column. And I think we're good there. And then we could just copy paste this and do the same thing for the right. Except it'll be +1 for the column. And we got to change node.right not equal to null and pass a node.right here. Okay, and now I think we're good. I think this is it. And we have to return the result at the end. Let's see, am I missing anything? I don't think I am. I think I'm good. Let's run this. Have an error. I typed in a colon instead of a semicolon. Another error. What's wrong here? Q is abstract. Oh, we're going to call this array DQ. And I forgot the actual, not the non-abstract class is array DQ. All right, what now? Integer call row.getKey. Cannot find symbol. What do you mean you can't find symbol? Oh, I said row get key. This should be call node get key and call node get value. Okay, cool. So this is, I'm gonna run it now. Submit. Let's see, did I get it right? Yeah. Cool. So that's how I would do this problem. And if this helped, you can give it a thumbs up. I guess we could go over time complexity, but it's just, what is this? O of, yeah, it'd just be O of n because of the, we're going through all the nodes, right? And space would also be O of n, yeah, because of the map and the result that we're returning. Oh, and the queues as well. Okay, cool. So yeah, if it helped you out, you could give it a thumbs up if you want, and you can subscribe. I do videos like this every now and then. All right, bye.